Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about the Mann-Whitney U-test. Even before I proceed to demonstrate what exactly is the Mann-Whitney U-test, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking the simple question, what exactly do we mean by the Mann-Whitney U-test? The Mann-Whitney U-test is considered as a non-parametric alternative for the independent samples t-test when the data is not normally distributed. I repeat, the Mann-Whitney U-test is popularly considered as a non-parametric alternative for the independent samples t-test for non-normal data. The Mann-Whitney U-test is also known as the Wilcoxon rank sum test. This is a non-parametric statistical test which is used to compare two groups. Now, let's talk about the null hypothesis that we will be using when we work on the Mann-Whitney U-test. The null hypothesis here is that the two populations are equal. The alternative is that the two populations are not equal. Some researchers interpret this as comparing the medians between the two populations. Note that the medians are not actually involved in the calculation of the Mann-Whitney U-test statistic. The two groups could have the same median and be statistically different according to the Mann-Whitney U-test. When do we use the Mann-Whitney U-test? The answer is very simple. When the data is not normally distributed, that's when we use the Mann-Whitney U-test. Let's talk about the last item in this video as far as the theoretical aspects is concerned. We'll be talking about the data requirements to perform the Mann-Whitney U-test. Firstly, the variables to be compared for the two groups must be continuous. An example for a continuous variable could be age or weight or height or heart rate. This is because the test is based on the ranking of the observations in each group. Therefore, make sure that the variables that you are using to compare the two groups is continuous. Secondly, the data is not normal because this is a non-parametric test. The third important point here is that the data is assumed to be similar in shape for the two groups. Fourthly, the two groups have no relationship with each other. Fifth point here is that the minimum sample size that is needed for a valid test is less than 5. Unless the sample size is less than 5, we should not go ahead. Unless the sample size is greater than 5. My apologies. Let me say this again. Only if the sample size is greater than 5, then and only then go ahead and perform the Mann-Whitney U-test. If the sample size is less than 5, Mann-Whitney U-test does not give reliable results. So the minimum sample size criteria is 5 or more. With this, let me introduce you to the data set that I'll be working on. As you can see here, I've got two variables. The first variable is the salary for female employees in an organization. The second variable is the salary for the male employees in an organization. These are the two variables that we will be using. What is the sample size in this data set? As you can see here, when you select this particular variable, the sample size is 216. So I've got 216 observations for women employees. The same holds good even for the male employees. So clearly, we pass the minimum sample size criteria. I'll take this data in STATCRAFT and show you how to run the Mann-Whitney U-test in STATCRAFT. As you can see here, this is the interface of STATCRAFT P. And I've already loaded the data set here. The first variable is the salary for women employees, and the second variable is the salary for male employees. If you've got 216 samples for each of the variables, which is a healthy sample size for us to go ahead and run the Mann-Whitney U-test. To execute this particular test, at the left-hand side top corner, you have what is called as the Analysis tab. Let me click on the Analysis tab. There are multiple options under the Analysis tab. I would like to click on what is called as the Compare Groups option. Once I click on the compare groups option, the third item from the top is non-parametric test. Let me go ahead and open this section. In this section, you see different options for non-parametric test. I will choose to run the Mann-Whitney rank test. This opens up a dialog box which is called as the Mann-Whitney rank test dialog box. As you can see here, the two variables that I will be using are shown in the canvas on the left-hand side, the female salary as well as the male salary. For variable number 1, I will be choosing women's salary. And for variable number 2, I can go ahead and choose the male salary. Under the section alternative hypothesis, let me choose this as two-sided. Once you have selected the two variables and have made the desired changes as far as continuity correction is concerned and alternative hypothesis is concerned, you are good to go as far as running the Mann-Whitney rank test is concerned. Let me hit the OK button. STATCRAFT takes a couple of moments to execute the Mann-Whitney rank test. As you can see here, this is the output of the Mann-Whitney rank test. Below, what you're able to see is the code which STATCRAFT has used to execute the Mann-Whitney rank test. In case you wish to, you can copy this particular code and paste this in Jupyter Notebook and execute the same analysis. This is the output of Mann-Whitney rank test. As you can see here, the Mann-Whitney rank test displays two columns. First is the statistic value and the second is the p-value. The statistic value is 8,260.5. Now, let me show you the p-value. The p-value is 9.68 into e power minus 31. So this is a very, very tiny value. Approximately, we can take this as 0.000 itself. Now, how do we interpret the p-value in this case? Since the p-value is very small, that is, the p-value is less than 0.05, we can go ahead and reject the null hypothesis. I repeat, we can go ahead and reject the null hypothesis and conclude that the two populations are not equal. In simple layman's language, we can also say that the median between the two populations is unequal. So this is how we can execute the Mann-Whitney rank test. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this video once again. Have a great day ahead.